Welcome back. Today we're going over 8.4, angle relationships. So this is the way angles interact with one another. We have 4 different types of angle relationships. First, we have adjacent angles. Adjacent means next to. So adjacent angles are angles that are next to each other. They share a common vertex, a common point, and they share a common side. They share the same wall, right? So that they're next to each other, they're adjacent. Next, we have vertical angles. Vertical angles are used when we have intersecting lines. Vertical angles are across from one another. They're on opposite sides. So when I have intersecting lines, my angle right here is a vertical angle with my angle down here because they're on opposite sides of these intersecting lines. They're across from each other. After that, we have complementary angles. Now, if you give someone a compliment, you're always right. Compliments are always the right thing. So complementary angles add up to right angles, 90 degrees. Finally, we have supplementary angles. Supplementary angles are straight lines, right? Supplementary angles add up to 180 degrees because they make a straight line. Now, complementary angles and supplementary angles do not need to be next to each other. They don't have to be adjacent. They just have to add up to 90 or 180, right? So I don't need them adjacent. I don't need them touching. I can use an angle way over here and an angle way down here and have a million angles in between. If they add up to 90, they're complementary. If they add up to 180, they're supplementary. If I have an angle and its pair supplements it to 180, it's supplementary. If I have an angle and its pair complements it to 90, it's a complementary angle. They are complementary. They complement each other to 90 degrees, right? Let's go ahead and get going into these angle relationships. We have 2 angles here. We have angle ABC and we have angle CBD. These 2 angles are touching. They share this line C and they have the same vertex, point B. So these 2 angles are adjacent. They're right next to each other. So these are adjacent. Adjacent angles, because they have a common side, line C, and they have a common vertex, point B. Sweet. So adjacent angles are very easy. They're just next to each other. Let's go ahead and keep going. Now, these angles are not adjacent. They're not adjacent because they are not next to each other. B is from here all the way across, right? B covers the whole thing, but A is just this little section. They aren't next to each other. A is inside of angle B. So they are not adjacent because they are not next to each other. A is inside angle B. These angles are not adjacent because they are not next to each other. Angle A is inside angle B. Now, these 2 angles are adjacent. They are adjacent because they are next to each other. They have this same wall, they share it, and they share this same vertex, this point, right? So these angles are adjacent because they share the middle line, a line, and a vertex. Right, so these are adjacent angles. Let's go ahead and keep looking at some adjacent angles. Now, these angles are not adjacent. A and B are not adjacent because they do not share a common wall. They do not share a common line, right? They are together on the same vertex, but A is adjacent with this X, and B is adjacent with this angle with the X. They're not adjacent with each other. There's a gap in the middle. They're not touching. So these angles are not adjacent because they do not share a line. In parentheses, not touching. Adjacent angles are always touching. Now, these angles are not adjacent either. These angles are not adjacent because they do not use the same vertex. They each have their own vertex. You have to share a common line and you have to share a common vertex. They have the same vertex, not the same line. These ones have the same line, but not the same vertex. So these angles are not adjacent because they do not share a vertex. Right? And so in parentheses, point. So we don't forget that a vertex is a point. Right? So they're not adjacent. Let's go ahead and move on from adjacent angles. They are pretty easy. Now angles B and angles B, right? They're all angles B. Angles DBA and angles EBC are blank angles because, well, we have angle DBA right here from D to B to A, and angles EBC from E to B to C. These two angles right here, both of them are 70 degrees. Well, they are on opposite sides of intersecting lines. So these angles are vertical angles. Whoops, these angles are vertical angles because they are across from each other. Right? They're across from each other. Well, vertical angles are across from each other and the equivalent. They're across from each other and they're the same angle. They're both 70-degree angles. That also means that these two angles are vertical angles. They're across from each other and they're both 110 degrees. Vertical angles are always equivalent or always the same. After vertical angles, we have this angle that adds up to 90 degrees. That is a right angle. Right angle. Complements are always right. So this is a complementary angle, or these are complementary angles. 70 plus 20 give me 90 degrees. These two angles give me a right angle. These two angles are complementary. Because they add up to 90 degrees. They add up to 90 degrees. Well, we said that complementary angles and supplementary angles do not need to be adjacent. They do not need to be touching, right? So this 80 degrees and this 10 degrees, 80 plus 10 gives me 90 degrees. So these are also complementary angles, even though they're not touching like the first ones, even though they're not adjacent like the first ones, they are still complementary. Because they still add up to 90 degrees. Right? So they add up to 90 degrees. They are complementary angles. Now I have 150 degrees and 30 degrees. They make a straight line. Straight lines are 180 degrees. So they give me 180 degrees. Supplementary straight line. These are supplementary angles. Because they add up to 180. Straight line. And 140 plus 40 gives me 180. If I were to grab this angle right here and move it over, it would give me a straight line. So it is straight supplementary. These angles are supplementary because they add up to 180 degrees. Right? So they are supplementary. They make a straight line. Wonderful. Now that we know our four angle relationships, we can start solving for missing degrees, right? Using those four angle relationships, I can find lots of different measures of angles. I'm looking for measure angle B. Well, I know angle B gives me a straight line here, that would be supplementary, or it is across from 38 degrees, it is a vertical angle. I need to know that vertical angles are equivalent. So both of these are 38 degrees, they're the same angle. So the measure of angle B is 38 degrees because it is vertical with 38 degrees. Now, angle B. I have a straight line, a supplementary angle, or I have across from 75, a vertical angle. Vertical angles are equivalent, so angle B is also 75 degrees. Angle B is 75 degrees because it is vertical with 75 degrees, right? They're equivalent. Vertical angles are equivalent. Wonderful. Looking at this next one. I know that these lines are perpendicular. These two lines are perpendicular, right? I know that they're perpendicular because it tells me I have 90 degrees right here. If I have a 90-degree angle, I have it on all of the angles for those perpendicular lines, for those intersecting lines. So these two angles give me 90 degrees. 90 degrees, a right angle. Complements are always right. So these two angles add up to 90 degrees. 90 equals angle B plus the angle with 52 degrees, right? I need to figure out what angle B is, so I'm going to go a vertical line through my equal sign, circle my variable, and inverse operation. Minus 52 degrees, minus 52 degrees. That leaves over my 38 degrees, so angle B is 38 degrees. The measure of angle B is 38 degrees because it is complementary with 52 degrees. And 90 minus 52 equals 38. Degrees, degrees, degrees. 90 degrees minus 52 degrees equals 38 degrees. Moving down to our next one, I can see that little square there. That tells me these lines make a right angle. Well, that's made out of two angles, angle B and 34. So these are complementary. They add up to 90. The total is 90 degrees, and that is equal to angle B and the angle with 34 degrees. To go through and solve, vertical line through our equal sign, circle our variable, and inverse operation, subtracting those 34 degrees. Right? I've taken away the 34 degrees, so I'm left over with 56 degrees. So angle B is 56 degrees. Because it is complementary with 34 degrees. And 90 minus 34 equals 56. Sweet. So I know, based off of my angle relationships, I could find the measures of angles B's because they are complementary, and complementary always add up to a total of 90 degrees. Then I could just go through and solve. Now my next one gives me a straight line. A straight line is 180 degrees. Straight is supplementary, and supplementary angles add up to 180 degrees. So in total, I get 180 degrees along this line. This line is 180 degrees. Well, if the total of it is 180, then the total equals angle B, this one here, plus angle 57 degrees. So B plus 57 degrees. I want to take away this 57 degrees. I want to get rid of this 57, right? So then I'm left with just angle B. So I'm going to take away the 57 degrees, right? Take away the 57 degrees. That leaves me over with 123 degrees. So angle B is 123 degrees because it is supplementary with 57 degrees. And 180, take away the 57 degrees, leaves over 123 degrees. Right? 180 degrees, take away the 57 degrees, left over my angle B, which was 123 degrees. Wonderful. Now, knowing these relationships helps me a lot when I'm given multiple angles. Right here, I'm given 6 angles, but I only get told how many degrees 2 of them are. And with those 2 measures, I can find all 6 measures. First, I always start with vertical angles, because vertical angles are the simplest. They're equivalent. I don't need to do any math for them. So I go through and I highlight my vertical angles. 55 is vertical with 1. 60 degrees is vertical with 3. Angle 4 is vertical with angle 2, right? After that, I can go through and I know 2 more. So instead of knowing 2 measures, I have 4 measures, right? 1 is 55 degrees because it is vertical with 55 degrees. 3 is 60 degrees because it is vertical with 60 degrees. And vertical angles are equivalent. So let's go through and fill those out. Angle 1 is 55 degrees because vertical with 55 degrees. Measure 3 is 60 degrees because vertical with 60 degrees. Now finding 2 and 4 have a little bit of math. Let's go through and find 2 first. I need to know what angle 2 is. Well, I can use any of my relationships. Vertical angles doesn't help me at all. Complementary, none of these are perpendicular. None of them give me 90, doesn't help me. But supplementary are straight lines, and I have 3 straight lines, right? So supplementary angles are gonna help me out. If I go through and I go, okay, these are a straight line. These 3 angles add up to 180. So they supplement each other. We have 180 degrees, and that's made from angle 60 degrees, angle 1, which is 55 degrees, and angle 2, which I don't know yet, but I'm going to use the variable t so that I can go through and solve for it. T for 2, right? Vertical line through our equal sign, circle our variable, and inverse operation. But before I start solving, I want to combine my like terms. So my constant 60 degrees and 55 degrees give me 115 degrees and angle t, right? And those equal 180 degrees. Now I can put that vertical line, circle my variable, and inverse operation. Minus 115, minus 115. That leaves over 65 degrees. So angle T is 65 degrees. So the measure of 2 is 65 degrees. The measure of angle 2 is 65 degrees because supplementary with angle 1, I'll say A1, angle 60 degrees, and angle 2. And then 180 minus 55 degrees and 60 degrees give me 65 left over. Well, now that I know 2 is 65, its vertical angle is 4, so 4 is also 65 degrees. Because vertical with angle 2, A2, right? It's vertical with angle 2, so it's the same. Vertical angles are always equivalent. Let's go ahead and keep going. Now, in this next one, I have the same problem. I'm given 2 measures of the angles, and I need to know all 6. Well, that's pretty easy to find if I start with my vertical angles. So let's go ahead and start with our vertical angles, then we can move to our supplementary, and then finally we can use a vertical angle relationship to know the last. My vertical angles are 106 and angle 3, angle 1 and angle 4, and angle 2 and 44 degrees. Based off of my vertical angles, angle 2 is 44 degrees, because vertical with 44 degrees. And angle 3 is 106, because it is vertical with 106. Now, angle 1 and 4, I can't use a vertical relationship, right? So let's go through and find 1. Well, I know 3 was 106. And I know 2 was 44. And I know plus 1 gives me a straight line. We have a straight line, right? So these 3 angles give me a straight line or give me 180 degrees because they are supplementary. So we have 180, the total 180, and that comes from angle 3, which is 106, angle 2, which is 44, and angle 1, which I'll find. I'll use an O for angle 1. And they are equal to 180. They give me a total of 180. Combine our like terms before we solve, and we get 150 plus angle 1 or O equals 180. Let's take away our 150. And I'm left over with 30 degrees. So angle O, or angle 1, is 30 degrees. Cool. The measure of angle 1 is 30 degrees because supplementary with angle 1, angle 2, and angle 3. Wonderful. Well, now that I know 1, its vertical angle pair is 4, so 4 is the same. 4 is 30 degrees because it is vertical with angle 1. Amazing. So we were able to find all 6 angles measures just based off of 2 measures because I know my relationships. Now, these relationships aren't always going to be super straightforward. Just because I know how many degrees it is doesn't mean I know what the variable equals, right? So use your knowledge of angle relationships to solve for x. Well, these are vertical angles. So this is 49 degrees. But I need to know what x is. So I know the total is 49 degrees, and that is coming from 6x plus 1. It's just an equation, and we can solve equations. Vertical line through the equal sign, circle our variable, and inverse operation. Zoop, zip, and minus 1, minus 1. That gives me 48 equals 6x. Divide by 6, divide by 6. That gives me 8 equals x. So x is 8. Nice and easy. Vertical angles are always nice and easy. But because you are great at solving equations, you can also be great at angle relationships as long as you can remember 4 relationships. Adjacent, next to, vertical, across and equal. Complementary adds up to 90 degrees, and supplementary adds up to 180 degrees. Wonderful. Let's knock out our next one. I can see that this is a right angle. So from here to here is 90 degrees. The total is 90 degrees. Well, it comes from 2 angles. Both of them are using x, so we need to solve for x. We know that together, they give me 90 degrees. That comes from 2x plus 3 and plus 5x plus 3. Before we ever solve an equation, we want to combine our like terms so that I don't have to move so many things. My x variables, 2x and positive 5x, and my constants, 3 and 3. That gives me 6, and that gives me 7x. and it equals 90 degrees. Vertical line through our equal signs, circle our variable, and inverse operation. Minus the constant 6 minus the constant 6. That gives me 84 is equal to 7x. Divide by 7, and I get 12. 12 equals x. So x is 12 degrees, right? We can plug in 12 and check. 12 times 2 gives me 24, plus 3 gives me 27. And 5 times 12 gives me 60, plus 3 gives me 63 degrees. 63 plus 27 gives me 90. So I solved correctly. X is 12. Finally, these two angles give me a straight line when I put them together. Straight line, so they are supplementary. They give me a total line of 180 degrees. So the total is 180, and that comes from the two angles, 5x plus 22 and plus 3x plus 14. Before I ever solve, I want to combine my like terms, my x variables and my constants. 5x plus 3x gives me 8x. 22 plus 14 gives me 36. That is equal to 180. Vertical line through the equal sign, circle our variable, inverse operation. Minus 36, minus 36. That leaves over 144 equals 8x. Divide by 8, divide by 8, and x equals 18. So x is 18. Based off of my angle relationships, I was able to find that x equals 18 because I know these are supplementary. They add up to 180. So our angle relationships help us solve for missing angles, or the measures of missing angles, right? We have those four relationships. Adjacent angles, angles next to each other. Vertical angles, angles across from each other on opposite sides of intersecting lines. Complements are always right, so complementary angles are always 90 degrees. And supplementary angles are straight lines, so they add up to 180. We need to remember all four of our angle relationships to be able to solve for missing angles.